Hello student, today's our topic is particle in one-dimensional potential box and it is the application of Schrodinger wave equations. So let's start it. Suppose that a particle in a rigid one-dimensional box, or we can say that it is an infinite potential well. So let us suppose that a particle is restricted to move in a one-dimensional box which having a length L, or we can say that at x is equal to, let us start with a x where x, the value of x is equal to 0, and it at x is equal to L. It means that the box length is the L, and this at x is equal to L it having a in penetrating walls, and x is equal to L also it's having a impenetrating walls. It means that particle cannot penetrate the walls at x equal to 0 and x is equal to L. This represents that if some body is not penetrating any area or any surface, that it means that its energy, that body energy is infinity at that surface. So particle is not able to cross this wall or penetrate this wall. That's why its potential energy is infinity at the x is equal to 0 and at x is equal to L. But this particle is colliding any of two wall is reflected back, as these walls are perfectly elastic. It means that when particle move from x to L, and when it's collide with this wall which is at x is equal to L, it bounce back the particle. So because it is a perfectly elastic wall, it bounce back the particle, and particle again moving towards the x is equal to 0. And when particle collide with this x is equal to 0 wall, well, it is also elastic, so it bounce back it again. It means that particle performing continuously to and fro motion inside this box. It means that its kinetic energy is maximum inside that box, but potential energy is 0. Therefore, we can say that inside the box the potential energy is 0, because particle is continuously moving inside the box, but its potential energy is infinity at x is equal to 0 and x is equal to L, because it is not able to penetrate this box. Now, because this particle is not going to change its potential energy with respect to time, it is continuously moving on a particular level. That's why we can apply a Schrodinger time independent wave equation on this particle, as this is topic already we have discussed when we are discussing about the time independent and dependent Schrodinger wave equation. So what is our Schrodinger time independent wave equation? It is equal to the E psi is equal to minus h cut square by 2m del square psi by del s square plus v psi. Okay, now we are just rearranging this equation by multiplying this 2m and h cut square with E psi and V psi. So now my equation is become like that, because potential energy inside the box is 0. Oh, therefore we substitute the value of V is equal to 0. So my equation become d square psi by dx square plus 2m h cut square E psi is equal to 0. Oh, now, just doing one thing, and we replacing 2me h cut square by k square. Why we are doing it? Because if we are calculating the k square with the help of 2 pi by lambda, and lambda is equal to h by p, then we will get 2m h cut square by e. So therefore we substitute the value of 2m h cut square by k equal to k square. Okay, now because this is a second order differential equation, that's why we suppose its solution is this. We have taken here sine and cos, or we can take in here the form is sine and cos, because we know that the wave packet is traveling in a sinusoidal form. Therefore we taken solution in the form of sine and cos. A and B are the arbitrary constant and k is a propagation constant. So we are going to calculate the value of A and B A because it is just a arbitrary constant. The value of A, B and K calculate with the help of boundary condition. Now what are these boundary condition? Boundary conditions are the basically initial condition and the final condition of any event. So our particle is moving in from X to L. So my final initial condition is at x is equal to 0 and final condition is at x is equal to L. Because particle is not able to penetrate the wall all, that's why the probability of finding the particle at the wall is 0. Therefore we can say that psi is 0 at x is equal to 0 rho. Similarly, at x is equal to L, the probability of finding the particle is 0 because it is not penetrate the ball. Therefore we can say that x is equal to L at x is equal to L size also 0. Now we are applying the first boundary condition size 0 at x is equal to 0 in equation 3. So at the place of x we substitute 0 and at the place of psi we substitute 0 also according to this boundary condition. So as you know that sine this when this k multiply with 0 it becomes 0 and this whole term the first term become 0. Only what left only b is left. Why? Because cos 0 is equal to 1, that's why b becomes 0. This we will get from by applying the first boundary condition. Now again we apply a boundary second boundary condition on equation number 3. So when we apply second boundary condition, we know that psi is 0 at x is equal to L. So at the place of x we substitute L and 0 at the place of psi. So now we know that from equation number 4 that b is 0. Therefore this term, this second term become 0. Only what left? A sine k L is equal to 0. So sine a sine kl is equal to 0. It means that either a is 0 or sine kl is 0 because these two term product is equal to 0. That's why we can say that any one of them is equal to 0. But we cannot say that a is equal to 0. Why? Because b is already 0 and if a is become 0 it means that psi becomes 0 and if psi is 0 it means that particle doesn't exist inside the box. But we have already know this thing that particle is moving inside the box. It means that particle is existence is present there. Therefore or we cannot take its function is equal to 0. So from this concept we can say that a never ever equal to 0. Thus sine kl is equal to 0. So when sine in theta is 0, so when the value of theta is equal to n pi by L and at the place of theta we have a kl, that's why we can say that kl is equal to plus minus n pi. Okay, so from this equation we calculate the value of k and it's come plus minus n pi by L. So from equation 4 we get the value of b and from equation 5 we get the value of k. Now we are going to substitute the value of b and k in equation number 3. So this is our equation number 3 and from equation number 4 b is 0 and k is plus minus n pi. So we substitute it here. So we get, after substituting this value in equation number 3 we get this equation number 6. How? B is 0 so this term becomes 0 and at the place of x at the place of k we substitute plus minus n pi by L. So my equation becomes psi a sine plus minus n pi x by L. Okay. Now only a is left and this is also one constant which is chosen by us. So we have to be calculate the value of a also. Now boundary conditions are and, but we know that particle is present inside the box. So probability of finding the particle is unity inside the box. and we know that if a function of the probability of finding a particle inside the box, then we can say that the function associated with that particle is a normalized function, and such condition is known as a condition of normalization. So condition of normalization means that volume integration of psi square dv is equal to 1, or we can say that the probability of finding the particle is equal to volume integration of psi square dv v. So we know that the probability is 1, that's why at the place of p we substitute here 1, and because we are talking about the one dimension, so instead of taking the three integration, we take here only the one integration, and it is about the volume, but we are talking about the one dimension, that's why at the place of dv we take the dx. Now we are substituting the value of psi from equation number 6 to here. So when we are substituting the value of psi, the equation becomes like that. This a square is constant, that's why we take it out. Now we are going to integrate this sine square, but the integration of psi square is not possible, that's why we use here one trigonometrical relation. And as you know that according to that trigonometrical relation, the value of sine square theta is equal to 1 minus cos 2 theta divided by a. Okay, so we use that trigonometrical relation here, and after that we integrate this equation. So this is our equation, and in this equation you have seen that I have substituted at the place of this sign, at the place of this sine square, I have substituted its trigonometrical relation in the form of cos. So what is the relation? The relation is 1 minus cos 2 n pi x by L, and upon we get 2 at the upon of this equation. So because it is a common, that's why we take it out. Now we are going to integrate this equation. So when we are going to integrate this equation, what we will get? At first we integrate 1 with respect to x. After that we integrate this cos value. So when we are integrate this value of 1, what we will get? We will get x. Now you have seen here that I am not calculating the value of cos. Why we are not? I have not written here the value of cos, because when you are integrate this cos, we will get a sine, and because integration of cos is equal to 2 sine, and when we are getting the sine, and we substitute the value of upper limit and lower limit, so sine and this n 2n and pi, when we are substituting the value of upper limit, at the place of x, we what we will return L, and here also at the denominator L is also present, so L is cancelled by this L. So what we will get? We will get sine 2 pi n pi, and this sine 2 pi n pi is equal to what? 0. So when we substituting our upper limit after the integration, what we will get? 0. Similarly, when we substitute the lower limit, it means that we substitute sine into n, and at the place of x we substitute what? 0. So what happened in such a condition? This term become 0, because sine 0 is 0. So when substituting the upper limit, the value comes 0. After substituting the value lower limit, value comes 0. It means that this last term is vanish out after the integration and substituting the upper limit and lower limit. So only what left? Only the integration of this one is left. So what is the integration of 1? It is equal to x, and substituting the lower limit and upper limit, we get L minus 0. A square by 2 already exists here. So after calculating this equation, what we will get? We will get this a square L by 2 is equal to 1. So with the help of this equation, we calculate the value of A, and what is the value of A? It is a under root 2 by L, which is our equation number 7. Now we substitute the value of A, which is equal to under root 2 by L, from equation number 7 to equation number 6. So when we substitute the value, what we will get? We will get this equation 8. So this equation is actually the eigen function, or we can get the wave function which is associated with the particle which is moving inside the one dimensional rigid box. The eigenvalues means the energy values, which related with this particle or the associated with this particle is given by the equation number 2. So what is our equation number 2? It is equal to k square 2m h cut square multiplied by the E. Because eigenvalues are the energy values, that's why I calculated E with the help of this equation. So what is the value of E? E is equal to, we multiply the value of h cut square with this k square. So we get h cut square k square by 2m. Now from fifth equation we know that the value of k is plus minus n pi by l. So we substitute this value at the place of k. So what we will get, after multiplying and doing all the calculation, we will get n square h cut square pi square divided by 2m l square. And what is this? This is the eigenvalue, or we can say that the energy values of the function which is associated with the particle. Now we are going to interpret the equation number 8 and equation number 9. Before interpreting the equation number 8 and 9, I want to say something about the one dimensional potential box, because we you people are thinking that why we are doing the application of Schrodinger wave equation for one dimensional potential box, and why we are going to place a particle inside such type of a box. So don't worry about that. Actually this is the analogous to the atom and a particle. Actually the particle is moving inside, the electron is continuously moving in a shell, and continuously revolving inside the shell, inside the atom. And at that time it is not changing its energy, and it is moving with a constant kinetic energy inside the cell, and it is not able to penetrate the atom also. Therefore the atom is behave like a box, and the electron inside that is behave like a particle. So from the analogy of this particle and atom, we have chosen the box and the particle. Okay, so this is discussions are basically about the electron and atom. Okay, so we can see that this energy values are actually gives us the value of electron inside the atom. So from the first from equation number 9, the first interpretation is that we are not getting the ground state type of thing inside the atom, because the ground state is started with the n is equal to 1. It is never ever started with the n is equal to 0, because when we are going to substitute the value of n is equal to 0, the energy becomes 0, and if energy is 0, it means that particle doesn't exist there. So our ground state is started with n is equal to 1, and its energy is h cut square pi square upon 2m l square. Okay, now because n is here, and n is equal to 1 2 3 4, it means that the energy values are not continuous energy values are not continuous. Means what? It means that the particle is not moving in a one line, or not moving in, suppose that there is a one this type of a band, and inside this particle is moving continuously. So particle is not moving continuously. Particle is basically jumping from one energy state to the second energy state inside a atom, as we know that. Why? Because the presence of this n. Due to the presence of this n, the particle, the energy values or energy levels are discrete. Okay, it means that we are not getting the continuous energy levels. We are getting a discrete energy level. It means that there is some gap between the ground energy level and first excited state. One thing I want to also say that if ground state is is E is equal to 1, it means that the first excited state is started with E is equal to 2. Okay. So energy levels are discrete. Third thing is the energy gap is increasing with the increasing the value of n. And so if we are going to calculate the value of first energy level, it will come h cut square pi square 2 ml square. But if it is we calculate the second energy level, we substitute the value of n is equal to 2. So n square become 4. So first second energy level having a energy 4 h cut square, or for some time we can say that this thing is always constant. Only the what change the value of n say. So for a minute we can say that the value this e2 value is 4 times of e1 value. Okay. So this is the 4 times of e1 value. It means that energy is increases. And when we are talking about the third energy level, so in third energy level, at the place of n we substitute the 3. So 3 square become 9, and rest of the things are equal to the e1. It means that the energy of third level is 9 times of e1. So we can see that when we are moving at upper level, or we can going ahead, then we find out that the value of energy is increased. It means that the gap between two energy level is increases. The first time the value is even, one in first energy level the value is even, but the gap, and what is the gap? When we subtract this 4 times even by even, then we will get 3 even gap. And when we subtract this e2 from e3, what we will get? We will get 5 time energy gap. So as we see that when we are moving towards the upper energy level, the gap between the two energy levels are increases. And this is our third point. Now we are discussing about the equation number 8. Now what is this equation number 8? Actually this equation number 8 representing the wave function, and wave function is equal to under root 2 by m sine plus minus n pi by x by l. And as it is a wave function, and wave function actually represent the movement of the wave inside this box. So I have drawn one diagram here, and in this diagram I have shown some waves are here. So first we are talking about the first energy level, or we can say that the movement of wave in a first energy level. So first energy level, well, the value of n is equal to 1. So in equation number 8 we substitute the value of n is equal to 1. So after substituting the value of n is equal to 1, we are going to find out the value of psi at different position of x. So first we find out the value at x is equal to 0. So when we are going to find out this, the value of x is 0 in equation number 8. Already n is equal to 1, and 0 is substituted here, so this term becomes 0. And when sign is 0 is equal to 0, it means that x is equal to 0, the value of psi is 0. Now we are going to find out the value at l by 2. So at the position of x, I substitute the value l by 2. So this L is in a numerator, this one is in the denominator. L is cancelled by L. Only one thing is left, lambda pi by 2, and this pi by sine pi by 2 gives us the one value. That's why we can say that at L by 2 the value of psi is equal to maximum. Now we substitute the value of x is equal to L. When we are substituting the value of x is equal to L, this L is cancelled by this L, and only pi is left, and sine pi is 0. It means that again the value of psi is 0. It means that the value of psi is 0 at x equal to 0, and psi is next time the psi is 0 when x is equal to L. Only the value of psi is maximum at L by 2, which means that a wave is moving inside the particle with a one peak. Now we are talking about the second level. So for the second value, the value of n is equal to 2. Now we are choosing this four equation at x is equal to 0. Though we are again going to substitute the value of x is equal to 0, and as we know that the sine 0 is 0, that's why psi becomes 0. Next value we substitute x is equal to L by 4. So when we are substituting L by 4, the value of n is 2. So 2 cancel this 4 2 times, L is cancelled by this L. Only what left, lambda pi by 2 is left, and sine pi by 2 is maximum. It means that at x is equal to L by 4 we get the value of psi maximum. Now we substitute value of x is L by 2. So we substitute when we substitute this, this L is cancelled by this L, this 2 is cancelled by this 2, and only one thing is left, sin pi, and sin pi is 0. It means that psi is 0 at x is equal to L by 2. Similarly, we calculated 3L by 4. So when we substitute 3 by L by 4, after cancellation all the things, only 3L by 2 is left, and sin 3L by 2 is minus of 1. It means that again the value is psi value is maximum, but it is in the negative side. At x is equal to L, and the value of a psi is also 0. It means that at second energy level we get a 2 peak at x is equal to L by 4, and at x is equal to 3L by 4, and at L by 4 we get a positive side, we get the peak, and at the negative sorry, at the 3L by 4 we get a negative peak. Similarly, when we move towards the third energy level, we will get 3 peaks. At 4 energy level, we get a 4 peak. What these peaks are interpreting, because psi is a complex function, so it is not able to interpret anything. That's why we know that the psi square is interpret all the things. It means that that at energy level 1, we are getting only the one value of psi. Means that we get the value of psi square, one value of psi square at energy level 1, but at 2 energy level 2 we get 2 peak. It means that we get the 2 peak at energy level 2, and so on. Now what is this psi square represent? Psi square represent the probability of finding the particle. At energy level E1 we get only one peak. It means that the probability of finding the particle is limited between the x is equal to 0 and x is equal to L. But at second level we get the two peaks. Two peaks, it means that the probability of finding the particle is between the 0 to L by 2 and L by 2 to L. Similarly, at E is equal to 3, we get a 3 peak. It means that the probability of finding the particle in these three areas. So, when the probability of finding the particle is increases, it means that the uncertainty in the position of particle is also increases. So we can say that when we are moving in a higher energy level, the position of particle is uncertain. And okay, but we see that the energy values are going to be increased, or we can say that we are less uncertain in the energy values when we are moving in a higher energy levels inside the atom. So when the values of energy are increases, or we are certain in the energy level, this certainty is transferred to the momentum, because E is equal to p square by 2m. So when we are moving in a higher energy level, we see that the uncertainty in the probability of finding the particle is increases, but uncertainty in the position momentum is decreases. So this is also proved the Heisenberg uncertainty principle. So today's our topic is end now. Thank you, students.